welcome to another episode of SCFG Live, Science Club for Girls Live. I'm Hannah with Science Club, and that was Mr. Music with your theme song. Nice! We're coming to you live from the Grand Canyon here, because today we're talking about rocks. That's right, today we're going to become geologists. Before we jump in though, it's been so long. It's been like 2 weeks, I think, since we've seen each other. I've been having so much fun here at Science Club for Girls. We actually were just having a 2-week-long rocket camp, which was a blast. Haha, get it? Because rockets. And it was awesome. All the girls got to make rockets. We got to launch the rockets. It was amazing. But more importantly, I'm really happy to be back with all of you here at SCFG Live. Now, there's another person that I really missed these 2 weeks, and that's Dr. Marbles. So let's check in with him and see what he's been up to.
Marbles here! Hey, Hannah!
Hey, Dr. Marbles, how are you?
How am I? I'm good. And I'm really good now because I'm seeing you and I'm seeing all you scientists.
That's awesome. It's been so long, and tell us what you've been up to.
Oh my God, it's been so long. Too long. Well, you know what I've been doing, Hannah?
What have you been doing, Dr. Marbles?
I'm looking out the window now because I've been outdoors.
Oh.
I've just been really enjoying nature, walking and getting some exercise and using my heart rate monitor. And one of the things I love to do, I love bird watching, one of my favorite things.
I didn't know that.
Oh, love it. Love bird watching. Brand new for me, but I love it. And then when I'm not bird watching, one of the things I've noticed as I've done my hikes, I've been hiking a lot. Ooh, actually, I notice, I guess you call them rock formations, but these beautiful, a little bit like what's behind you, these beautiful rock formations. And I kind of wondered, where do those come from? How do they get so beautiful? Those layers. What do you think, Hannah?
That's a great question, Dr. Marbles. And honestly, you've come to the right place, because today, that's exactly what we're going to talk about. We're going to actually become geologists today as we study the changes in rocks and learn about the things that cause rocks and our landscapes to change over time.
Oh my. Hannah, how perfect is this?
Could not have been more perfect, Dr. Marbles. You
could not have been more perfect.
I know. You would have thought we planned this.
Didn't we?
Shh, don't tell anyone. Anyway, we'll come back to you soon.
Awesome.
Bye. As Dr. Marbles was saying, today we're going to become geologists. Now, there's so much to study in geology. In fact, that's what geologists do. They study the history of the Earth and its life by looking at different rocks. And obviously, there's so much that we could do as geologists, but today we're going to focus on something specific, and that is called weathering. Now, weathering is the breaking down of rocks by things in our Earth. Could be things like water, could be things like air, could be things like chemicals. And today we're going to look at the different things that cause this weathering, this breaking down of rocks. Now, actually, I was going to show you some photos first, just to show you beautiful types of weathering. Take a look at these awesome landscapes. All of these landscapes have been formed and changed because of weathering, this breaking down of rocks. And again, this weathering can be caused by multiple different things like air and wind and sometimes even trees and animals too. In fact, take a look at this landscape. Look at the before and then look at the after. Look how much it's changed over time. And that's all due to weathering. Today we're going to focus on 2 different types of weathering: chemical weathering and physical weathering. The first type of weathering we're going to look at is physical weathering. And physical weathering happens when a rock is broken or cracked by the force of another living thing. By another thing, doesn't have to be living actually, such as wind, ice, water, or other rocks. Let's take a look at an example. In this jar, I have a couple of different types of rocks. Now, I'm going to add to this jar some chalk. Chalk is actually an example of limestone, which is formed from the leftovers from some living organisms. We'll talk more about chalk later. But I'm going to put some chalk into my jar with the rocks. Now's the fun part. I'm going to shake it up and see what happens. It's a little loud, so you might have to cover your ears. All right. Now, I've only been shaking it for a little bit, but take a look at the jar. That chalk has already started to break off into pieces, or what we call sediments. Sediments are teeny tiny pieces of rock. In fact, look at the chalk itself. It's already started to change form. You can see some holes that are forming, and it's kind of turning into a different shape. This is a great example of physical weathering, breaking down of rock by force, the force of the other rocks in this jar. Now, I'm going to show you another really cool form of weathering called freeze-thaw weathering. And for this, it's going to get a little messy, so you might want to have some paper towels nearby. For this experiment, you're going to need some plaster of Paris. You can find this in a craft store or in a hardware store as well. It's good for like molding kind of things. You're going to need some water to mix with the plaster of Paris. You're also going to need 2 plastic containers. You can use yogurt containers like I've done. You can also use plastic cups, or milk cartons too. You're also going to need a balloon that's filled with water. Don't throw it at anyone. You can do that when we're done with the experiment. And I think that's it. Let's get started. The first thing you're going to do is you're going to want to make your plaster of Paris. To do that, you're going to want to put equal parts of the plaster of Paris and equal parts water. It should turn into the consistency of yogurt. Perfect. All right. Now, your plaster of Paris in between your 2 plastic containers. I'm going to put a little bit of one and a little bit in the other. I need to even that out a little bit more. Put a little bit more in this one. All right. Now, one of these yogurt containers is going to be our control, meaning we're not going to do anything to it. This is like a real experiment here. And the other yogurt container is going to be our experimental container, meaning we're going to do something to it. And the thing that we're going to do to it is we're going to put the water balloon inside the plaster of Paris, like so. Push it all the way down, like that. All right, now these 2 are going to go into the freezer overnight. Now, I've actually already done this experiment, and I've already put them in the freezer, and I've already taken them out. But before we take a look at them, I want us to make a prediction. How do you think these 2 yogurt containers will differ? What do you think we'll observe in the yogurt container that had the water balloon in it, and the yogurt container that didn't have anything in it? Let's go to Dr. Marbles for our favorite section, Prediction Chicken. Hey, Dr. Marbles!
Prediction Chicken! Prediction Chicken!
All right, Dr. Marbles, what do you think's going to happen when we take our 2 yogurt containers out of the freezer? Remember, one of them has a water balloon in it, and the other one has just the plaster of Paris.
Thanks for reminding me.
Of course.
Well, okay, so here's my prediction. Well,
okay.
How shall I say? Here's our prediction.
It is a team effort, yes.
It is a team effort, Chicken.
Of course.
Hey, give me some space. Okay, so my thought is, now obviously they're going to be different. I mean, one's got a balloon in it.
Right, good point.
But here's what's happening. The balloon has got water in it.
True.
Water, when it freezes, it expands. And so my sense is that that water expanding is going to push or provide force onto the plaster. So, and here's my guess, and it's just a guess.
Of course.
It's a prediction. I think that the plaster of Paris with the balloon is going to crack. Just a guess.
Okay, just
But an
yes.
educated guess.
Exactly, using your background knowledge. Of course, a hypothesis.
Yep.
All right, let's take a look. You ready?
Yep.
All right. So here's the one. Oh, it's a green bowl. So here's the one that did not have the balloon in it. I already took it out of the container. It's beautiful, right?
Beautiful. No crack.
No crack. Good observation.
Yeah.
Now, the one with the balloon, I actually had a really hard time taking out of the container because look at that.
Crack!
That big crack that formed right down the middle.
We totally predicted it.
You totally predicted it. You know
But
what?
it makes sense, Hannah. It makes total sense.
It does make sense. In fact, here's a funny story that I wanted to tell you. One time, it was really hot outside, and so I was getting ready to go for a walk. And so I put my water bottle, completely filled to the top with water, into the freezer, took it out, and look what happened.
Oh, it cracked.
Exactly. But Dr. Marbles, why did it crack?
Well, it cracked because the water expanded in the cold.
Exactly. In fact, oftentimes when I was growing up, my parents would be a little bit worried that our pipes were going to freeze and crack in the winter, not the summer, because the water in the pipes was going to expand when it froze and eventually provide force to the pipe and potentially crack it.
Very expensive repair.
Very expensive repair. And that's exactly what's happening with our model and what happens in real life. When there's a small crack in rocks, water oftentimes seeps in. In the winter, that water then freezes and starts to expand, providing more force to that crack and eventually making even a bigger crack and potentially splitting the rock. Pretty cool. I know.
You know what, Hannah?
What?
I'll tell you what else that tells me is that those forces, they're strong.
Really strong. Exactly. Yeah. And that's physical weathering, right? Provide some kind of force acting on a rock and breaking it down.
Yep.
Cool. All right. Very cool. We'll come and check with you in a bit.
Awesome. See you soon.
Bye. So that was physical weathering for you. In that specific example, freeze, thaw, weathering. Water freezing, water thawing and melting, expanding that crack and breaking down that rock. Now it's the other type of weathering, and that's chemical weathering. Now, chemical weathering also breaks down rock and sometimes, breaks it down, but it breaks it down by actually changing the minerals in that rock. So cool. To take a look at an example of chemical weathering, you're going to need some vinegar. Now, vinegar is an acid. It's also a pretty strong chemical. So I'm going to suggest wearing some safety goggles when you're using vinegar in this lab. I'm just going to put them on now for extra safety measures. Okay, vinegar. You're also going to need some chalk. You're also going to need chalk, and that's pretty much it. Okay, let's take a look. The first thing you're going to do is you're going to place 2 pieces of chalk about equal size into your bowls. The reason why they're going to be equal size is because, again, we're going to do a control and an experimental group. So we want it to be basically everything the same except the one thing that we're changing. And the second piece of chalk. Awesome. All right. Now, in one bowl, I'm going to put vinegar. And I'm going to put a half a cup of vinegar, just enough to cover the chalk in that bowl. Oh, you know what? Before I do that, actually, I forgot. It's time to make a prediction again. So let's go to Dr. Marbles to see what he thinks. Hey, Dr. Marbles!
There's only one thing better than a prediction chicken, and that's a second prediction chicken.
That's right. In fact, I almost forgot because I'm so not used to it. I was about to do the experiment, and then I was like, wait, we gotta make a prediction.
I know. I was watching you. I'm like, what is she doing? We need to check in this.
You have to. It's so important, especially in an experiment. All right, Dr. Marbles, let me tell you the situation, okay?
Okay.
I got 2 pieces of chalk in bowls. They're both about the same size because I wanted to keep everything the same. Now, here's what I'm changing about the two bowls. One of the bowls is going to get a half a cup of vinegar, and the other bowl is going to get a half of water. What do you predict we're going to observe with the two bowls?
What do you think? Well, here's what I think.
Okay.
When you mentioned vinegar, first thing I think about, chemical reactions. Those lovely chemical reactions that we've talked about so many times. So my prediction is that there will be a chemical reaction from the vinegar. What that is, I've got no idea.
Well,
let's do it, Hannah. Let's do it.
All right, let's do it. Okay, so now we've got our vinegar and we have our bowls ready to go, and we're ready to add our vinegar and our water. Okay, that's a better angle. So let's go ahead and take a look. I'm going to add a half a cup of vinegar into one bowl, and I'm going to add a half a cup of water to the other bowl. Ooh, I'm already starting to hear some bubbles. I remember something about bubbles. Let's take a look. Whoa! Look what happened in this bowl. Oh my God, it's trying to get the Grand Canyon because it thinks green. And Ellen knows that vinegar smells bad. But you can already see the bubbles that are forming. Oh my gosh. And if I remember correctly, bubbles are a sign of a chemical reaction. So that was the vinegar one. Now take a look at the water one. Not much going on there. It's still staying like a blob of chalk. Now, these have just been sitting for about, honestly, a second. Let's take a look at one that's been sitting for even longer. These have been going for about, I would say, an hour or two. This is the one with vinegar. Take a look. Already starting to break off into all those different sediments, those teeny tiny pieces. And here's the one with water. There are still a few sediments, but for the most part, it's staying as one piece of chalk. Interesting. So Dr. Marbles was right. There was some kind of chemical reaction here. But what exactly was happening? Let's take a look. All right, so as we said earlier, chalk is a type of limestone. Limestone is a type of rock that is actually made from some of the leftover pieces of living things. So if you actually take a look at different types of limestone, you might be able to see some skeletons of different marine animals in there, which is really cool. Now, when the limestone contains calcium carbonate, which we've seen actually before when we did our eggshell experiment. Now, that calcium carbonate reacts with the vinegar, a chemical reaction, and it actually causes that calcium carbonate, well, it creates carbon dioxide and causes the calcium carbonate to start to dissolve, which means the chalk's actually going to start to dissolve. Now, obviously, we don't have vinegar falling from our sky, so this reaction wouldn't exactly happen in the real world. But what does happen is something called acid rain. So what is acid rain? Well, acid rain is caused by pollutants that are formed from car emissions or factory emissions, and those actually react together to form an acid. And that acid hooks on to the water molecules in our sky, falls down as acid rain. And it actually causes a very similar effect to what we saw with our chalk. It breaks our rocks down. Here's a great before and after photo of a statue that's been affected by acid rain. Even if you look closely at her face, you can see that a lot of the details on her face have actually been washed away by that acid rain. Here's another closer up example of a statue. Again, you can see that that rock has been weathered down, broken down by the acid rain. And here's one more example of some gravestones that also have been affected and weathered by that acid rain. Very cool. So again, we saw how different things, either physical things or chemical things, can cause weathering and change our landscape. In fact, a lot of this Grand Canyon has also been weathered, and that's why it looks so cool. So, there's obviously so much that we could explore as geologists, but we don't have time for that. But I luckily was able to sit down with some real geologists this week and ask them about their work and what they do. Let's go ahead and take a look.
I think we should just start off by you telling us a little bit about who you are, your name, relation to Science Club for Girls, and what you do.
Great. Okay, my name is Kate Harnock. I am on the board for Science Club for Girls as of about 1 month ago, and I have been mentoring at the King Open School for about 2 years, a little less than 2 years now. I'm from McLean, Virginia originally.
What do you do as a geologist?
I work in environmental consultant. So basically what that means is I work on sites that need to be remediated because there's been contamination on the site from historical manufacturing. Or what I really like doing is looking at human health risk assessment. So I look at how the contamination impacts like humans based on different kind of calculations.
Well, my name is Isabel Caban. I live in the Bronx, New York. I was born and raised here. And I'm currently a rising sophomore at Amherst College. And I'm planning to major in geology.
Oh, that's awesome. Well, today's episode was all about, so it's to have you on this episode. And I'm curious if you can just tell us a little bit more about what do you study as a geology major in college?
Yeah, sure. There's a bunch of different routes that you can take in geology. I took some courses on structural geology, which is about like how the earth kind of moves and the plates on the earth move. But personally, I'm interested in rivers and how like the sediments and the sand and the rocks in rivers can tell us about the history of the river and about the history of the climate and flooding and things like that. Something that I researched this summer actually, which was taking records from the rivers and how the rocks have been weathered and how the shapes and sizes of them have been changed due to flooding, due to rain, due to the water just flowing down the river. So it's really great that you guys are learning about this today.
Oh, that's really cool. It's neat how you can learn so much about the history of a place from just a single rock.
Yeah, so I mean, I know we were going to talk about this, but that's my favorite thing about geology. So basically, I feel like sometimes I am wearing these like special X-ray goggles. And so I'll look at a rock and I'll be like, whoa, I know from that rock what the world was like here millions of years ago. Actually, I have a rock here and we can use it as an example. So this is called a banded iron formation. And it's like, we call it BIF for short, basically. And it's my favorite kind of rock. And it is a sedimentary rock, kind of. It's like pseudo, like little bit of sedimentary, but anyway, it's one of the oldest rocks that you can find in the world, oldest types of rocks. So they get as old as 3.8 billion years ago.
Whoa.
Yeah, so all of these little black and like orange, basically stripes, they're basically represent different sedimentation in the environment over like a different period. So the black is if there was no oxygen in the environment, and the red is if there was oxygen in the environment. So you can like kind of tell what kind of organisms were living in the ocean or whatever from looking at one of these rocks.
Wow. The last question for you is if you have any advice for all of our young viewers out there.
I would definitely say just try new things. I actually got into geology by accident. I wanted to take a science course, but I wasn't really sure what type of science. And my advisor was just like, why don't you try this geology course? And I was like, sure. And I took it and I loved it. And I took more geology courses. And that's how I found my love of geology. So definitely just go out there, take those risks, try new things. You never know what you might find from it.
I always think my advice for my younger self would be just like get outside more because it's one of the coolest ways that you can do science. So I didn't really like find out my love for the outdoors until I found geology and started to really know what I was looking at around me. And that can be the case in so many different sciences.
Perfect activity to do in the summer too.
Exactly. Exactly.
Thank you so much for telling us about what you do and giving us that great advice. And I hope you can join us on the show again in the future.
Yes, thanks for having me.
Thank you so much for having me. This was great and good luck to everybody.
Thanks for being here.
Bye. I mean, geologists are notorious for licking rocks, but maybe don't try eating them.
That was so cool. I loved hearing about all their advice and their experience as geologists. Let's see what Dr. Marbles has to say about seeing some geologists. Hey, Dr. Marbles!
Oh my gosh, Hannah, that was so cool. I mean, Kate is so cool and so inspiring to see the kind of work she does. I have a couple thoughts about it. And Isabel, I mean, she's learning how to be a geologist. I mean, the determination is fantastic. She's going to be the next generation of Kates.
Exactly. It is really cool. And something that I love about Isabel is that she's created actually a really neat community at Amherst College. So she's actually part of a group called GWAC, which is Geologists Underrepresented at Amherst College. And it basically is trying to redefine who is a geologist. And it's an awesome supportive community.
So while she's learning, she's making a big difference.
Exactly. Yeah.
So cool. Well, I got two things I'm thinking about.
Okay, what are you thinking about?
One, I like to keep a journal. I've always kept a journal. Kind of reminds me of my life, important times in my life. And what I learned today is that rocks and the lines and the different parts of their formation are like the journal of Earth. They are the history books. And we can learn a ton from looking and learning about rocks. I wouldn't have thought that. And that's really cool. So many things.
Exactly. Yeah.
The other thing was that, well, we need the earth. And we've got to take care of it. Because the rocks are the earth. And we've got to take care of the earth because it supports us. It supports buildings we live in. And geologists, well, they're the caretakers of the earth. They take care of it. Teach us about it. Tell us how to make it strong. And so I want to just thank the geologists.
I agree. I think that definitely talking to Kate and Isabel has kind of made me want to stop and slow down on any walk that I go on because there's so much to observe about our Earth. And just like you were saying, the rock itself can be a little bit of a history book. And sometimes I'll just walk by it and not think anything about it. And this time or next time I go for a hike, I think I'm really going to stop and observe.
One suggestion?
Yeah.
When you're doing that, put some headphones on and listen to rock and roll.
Exactly. I think that's a great
whole experience.
Exactly. Well, Dr. Marbles, it was great to have you as always. I'm so happy that you could join us. And I hope that we were able to answer a few of your questions that you had at the beginning about how rocks look the way they do and why they do.
You did? And then some, as always. Thanks for having me.
Of course. We'll see you next time on SCFG Live. Bye, Dr. Marbles, and bye, scientists.
Bye, guys.